Hello friends, सबको नमस्ते. So today in this video we will create a YOLO model which will detect a number plate. Okay. So before explaining this code, let me show you the dataset. This is a dataset, test, train, valid. Okay, this is a YAML file which we do not need. We can create our own YAML file. This is a test. This is the images, and this is the labels, or you can say the coordinates values of the bounding box. Let me show you one bounding box coordinate. So this is the bounding box coordinate of of this image, and you can easily see that first value represent the class name. This two is x min and y min. This two is x max and y max. Okay, what is x min and y min? Let me show you. So this corner, topmost left corner of the bounding box is the x min and y min. Bottom right corner is the x max and y max. Now let me explain the code. So before that, let me show you that when you upload your data set in Google Drive and you want to connect that upload that zip file of your data set to your Google Colab, you can easily do that. You just make sure that, and even with the link during sharing, copy the link and just paste it here, and just copy this part till here. Just copy this part and paste it here, and just give the outer file name numberplate dataset.zip file. This is a library which I have installed for helping us to link your Google Drive with your Google Colab, or you can easily or you can say that download the zip file from your Google Drive with your Google Colab. Just run this. The zip file of your dataset will get downloaded. Okay, now we have to unzip that zip file. Okay, now sometimes in most of the cases when you download your data set from online, most of the cases you did not get the YML file. Okay, for that at that time you want to know how to create a YAML file. So what at that time this time we have a data has a YAML file. You can easily see that this one, but some most of the time we did not get that. So how you can create that, I am explaining that part. Okay, so this is the data which we required. Path means the folder name, and training images directory, validation image directory, test image directories. If you did not have a validation images, so skip this part, but it's important that you will give train images, okay, and test images. And C is number of classes. We have only one class, and that class is represented by the name plate. And we open the file, and that file will be named as number plate dataset YML file in the write mode as file. And you can see by using this YML dot dump means the data which we want to dump. You want to dump this data in that particular file, and this default flow style is false here. And what is the use of this? Let me explain you. So this is the helping code. Here it is false. Let me make it true. That what is the use of this? Representation of the data in the YML file changed. Say this. Now suppose this is the way the data is represented, but YOLO does not require this. Okay. YOLO required this way. Now let me open this. Now this way is this architecture of the file is required by the YOLO during training. Okay, so that's why it's false at that and here. Okay, now let me run it. It will create a YAML file. Where it is, let me see. You can see this. Okay, now we have to install Ultralytics to use the YOLO. Okay, now let me install it. It will download. Now this is the important part. See, here we are using YOLO, and the model which we are using here is YOLOv8 am.pt. So see this. We are using YOLOv8, and here required models and as am, al, X. And the difference in these models is the parameters: flop, speed, MAP value, size. Sizes remain same. You can see this 640 and 6040 is the size of the image, which on which this models are trained. We are using YOLOv8 AM, and the parameters is here is 25.9 is million parameter, having by used by weights having used by the YOLOv8 AM model. You can use YOLOv8X, YOLOv8 in LL, but it's depend on your CPU, because if you use YOLO V8X, YOLO V8M, the CPU speed decrease. If you have a compatible, means high processor and good processor and good GPU, then you can easily use this type of models, YOLO V8L, YOLO V8X. But I'm using Google Colab on online, so this why so right now I'm using YOLO V8M. Right now I can easily use YOLO V8 am Alan X, but I'm using YOLOv8 am this time. Okay, just for the explanation. Now here we have to use model.train. Here model are created, our model is created, pretend model is created. Now this time, now here we are using model. We are giving command that we have to train the model on our custom data set. Okay, we and for that, first thing we have to give your YAML file directory name here. Okay, then how many epoch you want to train. This time I'm training 2 times just for the explanation purposes. Okay, because but I already have this file which is trained on 50 epoch. Okay, now the size, you can easily see that 640 is the size of the pre-trained model, so 640. Now batch is 8. I want 8 batch, means in one batch I want 8 images. And this is when you run this model train command. Okay, or you can say run this cell, you will get automatically one file, one folder is created, runs, and inside that runs folder, detect folder is there, and inside the detect folder, this folder is created, one folder will be there and whose name is will be this, and inside that folder weight file is there, which is saved by our model during training. So save means true. We want to save the model weights. And save period management. Do not save every epoch, means we do not want to save every weight file of every epoch. We just want to save the best epoch. Okay, best epoch weight. And patience 20 means wait for the 20 epochs, and after that 20 epoch, if the accuracy does not increase or the loss does not decrease, you can easily stop the epochs. Okay, easily stop the training. Okay, and save the best epoch weights. Validation true means we have a validation folder, so we can also want validation to be trained, means during training we also want to validate the model. So now let me run this. See, it's download the YOLOv8am.pt. So you start epoch. Okay, now let me explain this part. After training, how you can get the model. See this, run, detect. See, this is a folder name which I have already tell you that how you get decide the folder name of this one. And inside this, let me first complete this. You will get the weight file. This is a weight. Inside that weight file will be there, from which we can easily capture it. You can see that run, detect, number plate, weight file. Inside that weight file, we want best.pt. Means best weight file we want. Okay, now after that, test image directory. We want to test an image, so our test folder is in a number plate dataset test images, and this is the color sample which I want to display on our number plate. Okay, this is a we have to first make the directory, means we have to make a list of all the file name present in that particular in that images folder. Then we want to plot 4 by 4 means we have to make a 16, we have to plot the 16 images. And here fig basically represent the entire plotation. Here X is just for the means accessing the one subplots or limit particular subplots. Here X is, you can easily see this, it is in a 2D format, but when you will use Rebel, here it will be in a 1D format, and why we are converting just for the ease of iteration. Plot the subplots which we are using 4 by 5, and figure size means 16 by 16. It means each plot size will be 16 by 16, and 4 by 4 means 4 rows and 4 columns. Now, 4 by 4 means we have to run the for loop in a 16 in a 16 time, so that's why you're using 16 here. Now we have to select a random image file from this image file, and after that we have to create the path of that image file, so that we can easily read that particular image. Okay, see this best pt and last pt, and which we want best pt, so that's why we have used this one. Okay, now let me close it. So after creating the directory name, you can easily use, but how we can create os path dot join text image directory. Text image directory will give me number plate test images, and after that we have to give the image name, so that we have to use os path dot join and image name. This way we create the image directory. After that we have to read that image, and we have already load the model. So after that we have to use model, just give the path name of the image 0. Here 0 means get the first result, one image. We have just passing the one image to get one image here, and to get the first image result we use 0 here, index 0 result. After getting the result is in a format like this. I think so it's not display here. Let me, after when I will run this cell, I will show you the result also. So result is in a format like result.boxes. There will be one dictionary which contain result. So result.boxes, and inside that boxes it will inside, after getting the result of that, we will use box.xy. Means xmin ymin ymax format of the data. It will give me, it will map in that xy and xy format. After that, class id we will get, label we will get, model dot name will give me the class id. Okay, model dot names will give me the class id. Okay, here we are using model dot name give me the class id. Okay, class id, from here we are get the class id, and model name means how many number classes which we have, but we have only one class, so it's give me label, and label will be plate. And we have to draw the bounding boxes, and for drawing the bounding boxes I already create the function. In just we have to pass the images, bounding box details, label, and color sample, this list, color sample list. Okay, after getting this we have the compiler will come to this function. So after that we have to first create the image copy. Then in when we get the this xy data, means bounding box details, we have to map this according to x min by min, x max by max. After getting this, we have to randomly select the color from this color sample list. We have to create the rectangle, just pass the image x min y min and x min y min, and the color, and the thickness will be 2. You will get the color. And after we have to upload, we have to display the text also, or we can see the label at the bottom of the bounding box. For that, just pass the image, then the label, then just x min and y max. X min will be this. Let me show you x min, and you can see that ymax will be here and xmin will be here. And if you use xmin and ymax, you will get this portion. Okay, you will get this corner. After getting this corner, just ymax plus 25, because we do not want to start from this line, this corner. We just want to display the text below it, so we have to want some gap here for better appearance. Okay, that's why y max plus 20. And already know, I in every video I explain you that y value in xy in image, according to image, y value 00 y value start from here, from top left corner. Y value 0 value start from here. Okay, now this is a format, this is a thickness, this is color, thickness, this is a, sorry, no, this is not thickness, this is a thickness. Okay, this is line A4, and this way we put the label. Okay, now after creating this, after plotting the bounding box and the label both, we will easily get the return the image. Now let me run it. Now let me run this also. For before that, let me print the result and break the loop. Let me run it. You can easily see that models, and this is a model result I am printing, and you will get model dot name 0 plate means, see this, result dot boxes. Result dot boxes will give me the detail. Where is the boxes? It is not representing the boxes. You can see this boxes. Here it is, nothing is showing, but when you will use this small result dot boxes, all detail will be all detail will be saved in box. Okay, now let me come here, control plus, or let me just use it here, result dot boxes. Okay, it gave me the better result. See this, it's a result of one image. XY means bounding box details is in this format, XYYWH format, XYWHN, XYXY. What we want this format means X min, Y min, X max, Y max format. Okay, so how we can retrieve it? Just result of dot boxes, and the box is there. And why we are using for loop here? Why? Because it might be possible that in one image multiple number plates multiple number plates is there. So that's why result dot boxes will give me first image, first number plate bounding box, second number plate bounding box details, other. This way, if suppose one image contain multiple number plates, so we have to loop that, we have to make use the for loop to iterate over it. So that's why I'm using for here. After for the first iteration, if I will get a detail of first number plate box, all detail will be stored in this box variable. To retrieve this, just use box dot x by x by 0 0 0 0, because x by is also in a tensor form, is in a list format. So x by on here it is a tensor format. To retrieve it, just give you 0 index, you will get it. Class ID, you can see this class ID, class, you will get the class index value. Model dot name give you class ID. This way you will get all detail, or you can say easily retrieve the details. Now let me for your better explanation, let me upload my model. Okay, where it is, this one. So let me copy the path and change this path. Okay, so let me pause this video and come back when this uploadation of the weight will completed, and this is our final step. So the uploadation is completed. You can easily see this. Now let me run it. uh, see this model, this weight file is trained on 50 epochs. Okay, so see the result. See this. It's correctly identify the number plates on a car. Okay, so now you can easily download this weight file from here. Okay, this best one, and you can easily use this weight file anywhere where you want to uh, detect the number plate of the car. Okay, so this way you will use this model. You can train this model on a custom data set, okay, and here we are used your YOLO. Okay, so please share, like, and subscribe. Thanks to all.